Good day, students. I hope everybody is doing great. Good. Today, the strands that you're going to talk about is geometry and measurement. And then the sub-strands here is geometric reasoning. The topic that we are going to talk about is the transformation by translation of 2D shapes in a plane. We have already discussed how objects move by a translation vector. So you are going to talk about how to identify the translation vector in a given number plane. These lessons have been taken from the new curriculum of BS6, Strand 3, Substrand 3, Content Standard 5, and then Indicator 2. Transformation by translation. Translation is the movement of a point or a shape from one place to another. Translation of 2D shapes or points is done or moved by translation vector. So before an object can be moved under the translation, there's a component called translation vector. They are always expressed in what? Coordinate form. And that move the object either to the left, to the right, to up or downwards. Okay, translation vector is added to the point or position vector before a point or shape is moved as image. So mathematically, a point plus translation vector is equal to image. The graphical interpretation by translation vector here, always the negative digit of x coordinate of translation vector is moved to left side of the point or of the shape, and the positive digit of x coordinate of translation vector is moved to right side of the point or of the shape. Sorry. Then the negative digit of y coordinate of translation vector is moved down of the point or of the shape. And then the positive digit of y coordinate of translation vector is moved upwards of the word point or of the shape. Okay, we have already discussed this. That is why be kind intention. Okay, good. So the facts about translation. So under the translation, once you have gotten your images, adding the translation vectors to the point to get your images and plotting the new image here. The other object that form as image, the shape of the object does not change from the original shape when translated. So once the fact that you are using the translation vector does not mean the change is will occur within the original shape and the image. The shape of the object does not change. One of the properties that you need to consider before or when the translation is done. The object does not turn or rotate during translation. So when you translate by translation vector, or you move the object or the point by translation vector, the object will be rigid and it will not turn or rotate, okay? It will just be moving, it will move forward. When you move forward, doesn't mean that you have turned. Then in translation, every point of shape must move the same distance because the same distance, of course, because only the translation vector will be adding. So one translation vector will be adding to the entire point at the same time. So they will move in the same distance, okay? Once they are all moving 5 left, they will all move 5 left. If they are all moving 5 right, they will all move 5 right. 6 down, they will move 6 down. All the points will move 6 down. If 6 up, they will all move 6 up. Okay, good. Sorry. So we are going to identify the images of single transformation, that is reflections and translation of 2D shapes in a plane. Okay, so what we have here, we have some of the objects have been reflected, others have been translated. Okay, so you are going to figure out those objects or those shapes that has been reflected on whether x-axis or on the y-axis, and those objects that has been translated by a certain translation vector here. Okay, good. So before then, let's talk about the transformation and what the reflection. Okay, so we said the reflection is also another component, changing objects from one place to another. So we did this one since last time, so let's refer our notes to this one and then refresh our mind on that. Then the reflection here, we said we have the reflection on the x-axis and then reflection that will occur on the y-axis. And also we have some of the facts about the reflection. The shape will not change. Here, the reflection, the distance between the mirror line is the same to the image, is the same as the distance from the mirror line to the objects. Yeah, the x-axis will be using as a mirror line to reflect or flip the object to the other side. So let's see something here. Now, once we have the shape A and you compare to the shape B, assuming that this line, the y-axis here, the y-axis happen to be the mirror line, okay, to flip the object or reflect the object. You know, the shape A here is a reflection of shape B, because once you place the mirror between the shape A and the shape B, you could see clearly that the object of A here, its image is what? The B, okay? The object will flip to the other side or it has been reflected. Second, the only thing that we can also use to check is that the distance from the mirror line, let's assume that the y-axis here is the mirror line. So if it is a mirror line here to reflect the object P, therefore the distance between the mirror line to the object must be the same distance between the mirror line to the image. So let's assume that the A here is the object. So the distance from here to the mirror line here, you know, you cross about two, sorry, you cross about two boxes. So we have the two boxes here. And then when you come to the other side, you also cross about the two boxes before you get to the shape B. Beside that, this point here will cross about two boxes. This point here will also cross about the two boxes. They are the same. When you come to the top here to compare, they will cross about two boxes. So here is 2, 1, and 2. Then here 2, 1, and 2. When you come to this point here, 1, 2, 3, 4. When you come to here, 1, 2, 3, 4. So every indicator shows that the object A here is a reflection of what? Object B on y-axis, because reflection on y-axis means all the y-axis will be as a mirror line to reflect the object to the other opposite, directly opposite, okay? So here will be the mirror line to reflect the object to the opposite directions here. Good. Now, we are still on shape A. The shape A and shape D under reflection. Now, let's compare something here. When you take this point here to the mirror line here, let's assume that the x-axis here is a mirror line to reflect the A and the D. When you take this point to the mirror line, the distance is only 1. When you come here, the distance to the mirror line is also 1. When you come here, the distance from here to the mirror line is 1, and here to the mirror line is only 1 box. Again, the distance of a mirror line to the object must be the same as the distance from the mirror line to the image, as one of the properties of what? The reflection. When objects reflect either on x-axis or on the y-axis. And here, we can also assume that the object here, we will not even assume, the object is now reflecting on what? On x-axis. And now, let's use the x-axis to be the mirror line here to flip, or when you flip something to the other page, okay, when you open a book in the other way around, so it will flip to the directly opposite. Now the shape A is also a reflection of what? Shape D on x-axis, or the shape D is also a reflection of what? Shape A on x-axis. Are you okay? Good. Now you can also talk about the shape D and then shape B. Now shape B and D, there's a reflection here. This one flipped to this side. So the shape D is a reflection of shape B in the line x is equal to y, okay? So this line here, or the object B here, is reflected to what? The shape D. Now we are done with the reflection. We know the reflections occurs on the axis, the one that occurs on the x-axis and the one that occurs on the y-axis, or in the line x is equal to the x, okay? Where the object will be in a vertical opposite like this. Here, there's no reflection, okay? When this one flip, it will not turn like that, okay? It's only the D and the B flip in the vertical directions here, and here the x is equal to the y. But the A and B, there's a reflection where the A is reflected on the y-axis, and then the B is also reflected on the y-axis to get the image of A. You can also say that the shape A is a reflection of shape D on x-axis, or shape D is also a reflection of shape A on what? X-axis. The last aspect of the reflection, which is the shape D, is a reflection of shape B in the line x is equal to what? Y. Good. Now let's talk about the translation here. Now let's first talk about the shape B and shape what? C. When you say shape B and C has been translated, because the shape B here is a translation of what? Shape what? C. So let's see the movements first before you can also justify that the shape B here is a translation of shape C, or the C is a translation of what? The B. Let's see the movement. You said the translation only deal with the movement where the same translation vector will be moving. So let's take one translation vector here. From a distance from the B to C, let's take this point, okay? This point here, let's see how movement. It will move to the right side of what? The x-axis. So here it has moved one. This point will not be counted because the next step, or the immediate line, will be the next step. So here is 1. So now you have the x-axis. Moving to the x-axis, here is the 1, okay? And then here is 1, and let's count up there to get the point here, okay? Let us assume here is the point P, okay? So, and here too is the P prime, the P prime. So point P here is formed by 4, which is 4 and 1, okay? 4 and 1. And then the P prime is also formed by what? The 5 and what? And 3. But before you can get a 5 and 3, we need to add a certain translation vector to the point P before you can get what? The 5 and 3 here. So let's see how the movement, we can use the calculations to verify or figure things out here. But let's do the manual calculations here. From point P, let's see the movement. It first moved to the 1 right. So 1 right means the positive 1, okay? Now we have the positive 1 here. And then from 1 here and 2 up, 1, 2, okay, before you reach the P1 and 2 up, which means this is the translation vector, okay? The translation vector here. Which means that the point P is moved by what? 1 and 2. 1 and 2. So let's see what are the points. When you add the 1 and 2 to point P, you get 5 and 3. When you have the point P to be 4 and 1, so point P is 4 and 1, okay? Plus, we said it's moved by what? 1 and 2, okay? When you add the 1 to the 4, you get 5 here, okay? And then when you add the 2 to the 1, you get 3 here. So you see clearly that you have gotten the image, the P prime to be 5 and 3. Again, let's check the other point here. Let's call this point here point Q here. This point Q here is formed by 2. Oh, sorry. Is 2 and 1, okay? And the same here will be the Q1, okay? That will be the Q prime. Now let's use the counting to check. From point P, here is 1, which means 1 right, 1 to the right side, so 1 right here, and 1, 2, 2 up, okay? So when you add this one, let's see the coordinate that form this Q1. The coordinate that form Q1 is what? It's 3 and 3. Now you have the 3 here and 3, okay? Good. Now let's do the calculations. When you add a translation vector to the point Q, whether you can get a Q prime. We have the point Q here, which is 2 and 1 plus 1 and 2, okay? So when you add them, you get 3 and what? 3. Are you okay? Good. So it's obviously that the shape B is a translation of what? The shape C. Okay, good. Now we can also think about the shape E. It's a translation of what? Shape B. Shape E is a translation of what? Shape B. Let's do the counting. Let us assume that here, now we have the P here, okay? Let's take this one to be P2, okay? The P2, let me write the P2. Here is the P2, okay? Now the P2, let's count. So you count to the right side, okay? Now the X face. Here is the point. So then immediate line will be 1, 2, 3, 4, 5, 6, 7, 8. Now we have the 8. 8 what? Right. So once you have gotten the 8 here, then you are comparing the E and B. So once you are getting the 8 here, then you move upwards to get the Y. So here is 1, 2, 3, 4, 5, which is 8 and 5. Okay. Now, which means that the point E here is a translation of what? Point what? B by translation vector 8 and 5. Let's do the calculations. Here, the point E here is what? Is -4, 4 by -4 and -4. Okay, and -4. And then let's see, this one is already 4 and 1. Now, when we add the translation vector to -4 and -4, we're supposed to get what? The 4 and 1. So when you have here to be -4, -4, and -4 plus 8 and 5. Okay. So you add the top one before you can get the image. And we said the image is this one. So when you add the -4 and +8, you get one +4. And then when you add the -4 and then +5, you get +1. Okay. Because you use the 4, we use the 5 to diminishes or decrease the number of negatives here, and that will be the 4 and 1. And now you are getting the 4 and 1 here. Are you okay? So the point E is a translation of what? Point B by translation vector 8 and what? 5. The same point E is also a translation of what? Point C. So let's check this one. Let's use this coordinate. The P2, which is -4 and -4 here. And then the P1 here is what? -5 and then +5 and 3 here. Good. Now let's find the translation vector between the point E and the C. Now from point P2 here, this point here, you move 1, 2, 3, 4, 5, 6, 7, 8, and then 9. Okay, so now we have 9. We have 9 right. That is the positive. 9 right. And then you check upwards to this point. So immediate point will be 1, 2, 3, 4, 5, 6, 7. And that is 7 up. Okay. And that is the translation vector between the point E and then point C. So point E here is translation of point C by translation vector 9 and 7. Let's confirm whether it's 9 and 7. Now, when we add the 9 and 7 to -4 and -4, we're supposed to get +5 and +3. So we have the -4 and -4. We say always we add a translation vector to the point to get what? The image. So once the E is a translation of what? The C, therefore, let's use the C as the image here. So when you add this one, 9 and 7, let's see the answer here. When you add a +9 to -4, you get +5. You get +5 here. Let me clean it and do it well. All right, so okay, you get what? You get 5 because -4 plus 9 will give you +5. And here, when you add this -7 to -4 and +7, you get what? +3. And that will be the answer, okay? And here is what? +5 and then +3. So which means also that the point E is also a translation of what? Point C. Now the last translation that you can also talk about here, sorry, is F and A. Now let me use this here to be point A. Okay. This point A here is formed by -4 and then +1, okay? And let me use here to be the A prime, okay, the image of A prime or the image of the point A here. Here is also formed by 1, +1 and -4, okay? Good. Let's check the translation vector here. So the translation vector, let's count the object first. Here is the point. We are counting to what? To the right side. So here, 1, 2, 3, 4, 5. Okay, which means we have the 5 right. Okay, 5 to the right. And then from this point, the next step would be what? We are counting downward because this is where you can locate the A prime. So since here is 5, then here is 1, 2, 3, 4, 5. That means 5 down, okay? So 5 down means -5 here. Are you okay? Good. Now, it means this one is the 5 right, 5 down is a translation vector here. So you can either say the point A is a translation of what? Point F by translation vector of 5 and -5. Or let's prove whether our answer here is correct. We said always the point A must be added to a certain translation vector before you can get the A prime. So let's assume that the point A is negative, or the point A is -4 and 1, plus the translation vector that we counted, which is 5 and 5 right, and then 5 down. 5 down is the negative, okay? Good. So when you add the -4 and 5, you get +1, okay? You get +1 because you use the +5 to pay off the -4, you get a cash of 1 left, okay? Then when you also have the +1 plus a -5, you get a -4 because the +1 will reduce the -5 to get to a -4. Therefore, the point A is a translation of what? Point F, because we are getting the same the same point, okay? Good. This is a translation of what? Shape F. So shape A is a translation of what? Shape F. So this is how to identify a single transformation, that is the reflection and what? Translation of a 2D shapes a shape with only length and breadth. Now we have done. Okay, so per the summary of what we did, the shape for the reflection, we were able to realize that the shape A is a reflection of what? Let me clean the board. Okay. Good. We also realize that the shape A for the reflection, shape A was a reflection of what? The shape B on y-axis, and shape B is a reflection of shape D on x-axis. Shape D is a reflection of what? Shape B in the line y is equal to x. For the translation, we also conclude that the shape B is a translation of shape C by a translation vector, which is 1 and 2, and that is 1 up, 2 right. So we did that calculations, and that is all. So that was what we were able to also estimate for that. Are you okay? Good. So thank you for watching. We'll talk again. Good.